Montserrat and Chairman of the Board of CARDI Board of Governors, Mr. Barton Clark, Executive Director of CARDI, Mr. Naitram Ramnanan, Scientist / IAS Coordinator and Regional Representative, Caribbean and Central America, CABI, Trinidad and Tobago, Dr. Roberto Sandoval, Food and Agriculture Organization of the United Nations, Barbados, Susan Singh Ranjan, Deputy Executive Director, Caribbean Regional Fisheries Mechanism, Belize, Dr. Oluropo Ogundipe, CEO and Senior Geospatial Analyst, Global Geo-Intelligence Solutions Limited, GGIS. Esteemed guests, good morning. Welcome everyone. Thank you for joining today's webinar, which marks the first in CARDI's webinar series. These webinars aim to highlight the work of CARDI in strengthening CARICOM's food and nutrition security. My name is Ria Jack and I'm the ICT Infrastructure Specialist at CARDI. CARDI was established in December 1974 to serve the then member states of the Caribbean Community CARICOM. CARDI is named as an institution of CARICOM in Article 4 of the revised Treaty of Chaguaramas establishing the Caribbean Community, including the CARICOM single market and economy. CARDI is positioned to enhance the socio-economic well-being of the Caribbean people through research for development that improves the competitiveness and sustainability of regional agriculture. CARDI staff is located in 14 CARICOM member states, and CARDI collaborates with local, regional, and international strategic partners, and has executed work on components of the value chain in relation to small ruminants, roots and tubers such as cassava, sweet potato, yam, dasheen, and herbs and spices. Some notable work include, but is not limited to, germplasm conservation and management for roots and tubers, small ruminant feed systems, drought-tolerant studies for roots and tubers, integrated pest management, and the coconut industry development across the Caribbean. Today, we are presenting disaster risk management in agriculture using satellite data, which will be presented by Dr. Oluropo Ogundipe. This webinar highlights the work done under the IICA CARDI project titled Damage Loss Assessment using Satellite Imagery and Other Advanced Tools. Satellite data was used by the UK-based GGIS to assess the impact of the very devastating 2017 hurricane season on the agriculture sector of 3 Caribbean countries, which was severely affected at the time. These countries are Dominica, Antigua and Barbuda, and St. Kitts and Nevis. The problem, methodology utilized, and results of analysis will be presented along with a discussion on the challenges faced, future opportunities, and relevant actions required in order to build resilience into the sector in the Caribbean. Just a little housekeeping before we get started. As you would recognize, this webinar is being recorded. All attendees will automatically be muted during this webinar. Attendees will not be able to chat with each other. You can use the question and answer box for submitting your questions to the speaker. I will bring them up at the very end of the presentation for Dr. Ogundipe to answer. Please use the chat box for any technical issues. So if you're not hearing, if you are not seeing a video, you could send a chat in the chat box. I would like to introduce Mr. Barton Clark, the Executive Director at CARDI, to deliver the opening remarks. Mr. Clark.
Good morning. Special good morning to Minister Bufang, who is the Chairman of CARDI's Board of Governors. Colleagues, let me express my own welcome to this webinar series, part of our adjustments because of the scourge of COVID-19. That is not the only matter which is of deep concern to Caribbean development. We also have the issues of climate change and the ongoing climate issues. Whilst this study relates to the damage caused by hurricanes in 2017, note that we've had significant hurricane events every year since then. in addition to that, in very recent, over the last couple of weeks, the Belize, Jamaica, Antigua and Barbuda, Montserrat, Barbados, Trinidad, all have been experiencing very severe weather conditions. And then that is also set against the background of I have to indicate this, the issues around chronic non-communicable diseases, which are impacting our efforts to address the matters of food security. This whole, addressing disaster risk management, bringing to life data that facilitates planning and policy making is very much part of the resilience agenda for CARICOM that has been set forth by the Conference of Heads of Governments from the meeting when they met in Jamaica in 2018. And that resilience agenda came out of a very wide effort led by the Caribbean Disaster Management Agency, and including the other CARICOM institutions, trying to strategize on what would be the particular interests and opportunities and work to be done by various institutions in order to be able to address this issue of resilience. And note as well that, again, also as part of the resilience agenda, and again related to the particular application that we're discussing, is the fact that Dominica has put up their hand to be a model for global small island developing states as with respect to resilience for the agricultural sector. And this tool and this data is significant, and that allows us to examine what are the circumstances that attend agriculture and food security across the Caribbean. Before a disastrous event, during the event, and after the event. This will help mitigate, particularly now in the face of COVID-19, when we are no longer can deploy with any comfort boots on the ground. The utilization of this technology and so on is critically important. And it is grounded in CARDI's strategic framework. CARDI's strategic framework and so on sets out that we will be investing in information and communication technologies such as satellite imagery, such as Geo-spatial technology, in order to be able to improve CARDI's ability to deliver services, R&D services to the agricultural sector, as well as to improve the lot of the farming community in their ability and so on to meet their own livelihood needs and contribute to national, personal, as well as regional food security. We are not doing this by ourselves. We express appreciation to IICA, who would provide the resources and things that would have allowed us to engage and so on, Dr. Oluropo. But it also points, I think, to the organic relationship that we have with the Caribbean Disaster Management Agency. We have two of our staff, I think, who attend their meetings and who are ready to be deployed to assist member states in assessing damage. This is Mr. Ansari Hossain, who's our livestock specialist, and Mr. Gregory Linton, who's our crop specialist, and so on in this regard. But it also points to the relationship, I think, between CARDI and the Caribbean Institute of Meteorology and Hydrology and the Caribbean Climate Change Center and helping to address these issues. Our work tool is grounded in some of the instruments advanced by the World Economic Forum. They spoke about greater utilization of big data, the need for investments in precision agriculture, the need for investments in mobile service delivery, so that extension are better able, I think, to reach farmers, particularly in remote circumstances, particularly now that we're having to face with COVID. So that it then speaks to the dynamic and iterative monitoring of the circumstances that attend the agricultural sector that would then allow for us, I think, to be in a better position to be able, I think, to effect policy, to be able to conduct research and to provide answers to the farming community and to the policymakers regarding addressing the issues of food security. We are therefore very, very supportive of this, and we also would want to continue this work, but because we're just right now exposing you and think of what is possible. And we're very happy that we have had the collaboration, I think, with Dr. Oluropo and our team in order to be able to deliver this work. We invite you to listen attentively regarding this presentation, and we look forward to your future engagement with respect to this matter. Thank you very much.
Thank you, Mr. Clark. Now, without further ado, we will turn the time over to Dr. Ogundipe, CEO and Senior Geospatial Analyst at the Global Geo-Intelligence Solutions Limited, GGIS. Dr. Ogundipe is the founder and CEO of Global Geo-Intelligence Solutions Limited, a geospatial data analytics company based in the UK. She has been engaged in satellite surveying and mapping sector for over 20 years, working in both industry and academia. Dr. Ogundipe gained her PhD in engineering, surveying, and space geodesy from the University of Nottingham in 2003. She became a research fellow at the Nottingham Geo-spatial Institute, which is housed at the University of Nottingham, in 2007, where she worked on a wide range of projects involving collaboration with industry and other academic partners. Projects include bridge deformation monitoring of the Avonmouth Viaduct and Severn Suspension Bridge using high-precision GNSS, multi-part error mitigation using a bio-inspired algorithm, monitoring of illegal forestry activities using satellite data, monitoring of dairy cows using ultra-wideband sensors, and much more. She is a member of the Royal Institute of Navigation. In 2015, she won the University Challenge of the prestigious Copernicus Masters competition. Now I will turn it over to Dr. Ogundipe.
Good morning or good afternoon, everyone, depending on where you're located. It's a privilege to talk to you this afternoon and to share some of the outputs of the work that my company carried out together with CARDI. So I will share my screen and talk you through the problems and the process and the analysis of the data that we derived. Okay, so just to quickly introduce my company. So we are Global Geo-Intelligence Solutions. We're a geospatial data analytics company. We provide geospatial intelligence and solutions for resource and infrastructure monitoring and management in all areas, agriculture, transport, and a wide range of areas. We utilize data from Earth observation satellites, global navigation satellite systems, and other sensors and devices and other data sources to provide decision support intelligence to end users. So in this project, we looked at assessing the impact of the 2017 hurricane season on the agriculture sector in the Caribbean using satellite data. So myself and my team, who are experts in satellite data processing, and then Mr. Shimon Biza, who at the time served as an intern. He was a UE third year UE Geomatics student at the time. So the problem, I think Mr. Barton has helped to sort of introduce the problem that the Caribbean faces really increasing levels of hurricane, such as in 2017, the Caribbean had an unprecedented hurricane season with up to 5 hurricanes of category 3 and above, causing damage and destruction in the region. With the effects of climate change and increasing global temperatures, it suggests that such extreme weather may become more widespread and more frequent. Therefore, there's the need to develop systems that allow for planning, preparation, recovery, and rehabilitation. So if we look at 2017, we had Hurricane Irma having an impact from the end of August to mid-September. It reached category 5 status and had wind speeds reaching up to 185 miles per hour. We had Hurricane Jose from the 5th of September to the 26th of September, and this peaked at category 4. And then we had Hurricane Maria, which was in the region from mid-September to the beginning of October, which reached a Category 5 status. And the image on the right shows a capture of 3 hurricanes in the region following each other back to back. So with these hurricanes, there was significant widespread damage and devastation to multiple islands, causing direct and indirect impact on agriculture. So the question is, how can information be gathered to enable speedy assessment and quantification of damage to the agriculture sector? So as part of the solution, we're looking at satellite Earth observation. So some of the strengths of satellite Earth observation is that there is global coverage, allowing and enabling remote imagery for remote and inaccessible areas. There is regular and repeat coverage, and there is also the availability of free data for medium resolution data, and high resolution data is also available as well. So this study, like was mentioned before, focused on Dominica, Antigua and Barbuda, and Kitts and Nevis, as these were one of the islands that had significant impact in the 2017 hurricane season. So the data that we collected satellite data in both the optical and the radar spectrum. For the optical data, this is using the illumination of the sun. Different objects, including vegetation, absorb and reflect the sunlight in different ways. And using knowledge of those characteristics, we can come up with certain ratios and indices. And one is called the Normalized Difference Vegetation Index, or NDVI. It's by examining the ratio of the reflected infrared to red wavelength provides a means of measuring vegetation health. So by analyzing NDVI over time, we can then see a trend as to whether vegetation is thriving, whether it's under stress. And in addition, it can help to identify things like areas of deforestation, as well as changes in plant growth and phenological stage. And again, by monitoring NDVI post-hurricane impact, it can again help to track the damage impact and areas of recovery. So this image just helps with understanding of the NDVI, that healthy plants absorb certain parts of the spectrum and reflect certain parts of the spectrum. So a healthy vegetation would reflect more of the near infrared and absorb more closer to the red, while unhealthy would have a different characteristics. This is both unhealthy in terms of its growth and also in terms of its structure. So by looking at the NDVI and what's called the false color composite, we took snapshots of the NDVI at different periods. 2 images are before those critical periods where hurricanes Irma and Maria passed through. This is for Dominica, by the way. And then there are 3 snapshots of after. And if we look at the legend, so we see that the green indicates high NDVI, yellow is medium level NDVI, and red is low NDVI. And we can see in the before images that we can see high NDVI values. And even though there's significant cloud cover, we can still see this feature. And then post-hurricane, there's a clear impact reduction in the NDVI values right across the whole country. Cloud cover is one of the issues that when dealing with optical data, one has to sort of work around and try as best as possible to find cloud-free data. And depending on the work that's done, different techniques can be applied to deal with this. So if we look at radar data analysis, with radar data, there are many observables that can be analyzed, and one is the backscatter. So this is where the radar satellite is an active satellite. It does not require illumination from the sun. You can get the image can go through cloud cover, and so it's not limited, unlike optical data. And likewise, you can get data at nighttime as well. And so when the radar pulse strikes the surface, and then you get energy scattered back, and the nature of the scatter depends on the type of surface, whether you have a smooth surface or a rough surface, and that gives you information, but in terms of the backscatter intensity, as well as the polarization. So by looking at some of the backscatter changes before and after the Hurricane Maria and Irma for Dominica, again, looking at the legend, areas that experience significant change are the red and the yellow, and we can see that there is, from this image, we can see that there is significant change and that has been experienced in the island of Dominica, that the hurricane has had severe impact right across the whole island. Again, applying some classification techniques to the backscatter image, and then comparing this with data provided by UNOSAT. So UNOSAT is a body of the UN that is part of the UNITA, providing training and capacity building. And through UNOSAT, post sort of catastrophic incidents, there is data available to sort of governmental organizations, and UNOSAT had available this data that we could compare our analysis with. This data is basically where high resolution Pledis 0.5 imagery data has been made available to experts who know how a landslide looks like. And so they have manually gone through the different images to mark and highlight areas that have experienced landslides. And so by comparing these two images, so the image from UNOSAT is the red, those are the areas that have been manually identified as landslides, while from our automated analysis of the radar data, we have highlighted the yellow. These are the yellow areas. And we can see that there is good agreement between the two. And in fact, our analysis highlights some more areas that were not marked by the UNOSAT analysis. And this is because for us, we were not just identifying areas of landslides, but general areas of damage. So this will include areas that had damage due to wind damage, flooding, and other effects. And so from our analysis, we were able to determine the amount of area that had significant damage. And so another characteristics of radar data is something called volume scattering, where when you have a forest canopy or vegetation, the scattering of the signal as it passes through the vegetation is called volume scattering. And this feature is used in our next analysis, which is called entropy alpha decomposition. And so we have mapped different characteristics. So red is mapped to the entropy, and blue is mapped to the alpha angle. Where there's a high alpha angle, it implies volume scattering, which is a feature of dense vegetation canopy. And so we can see in our before images that there is significant blue widespread across the island. But then in our after hurricane impact image, we can see that there are high amounts of red. And again, this again confirms that the widespread impact of the hurricane where on the vegetation, where there is indicating loss of vegetation and forest canopy. And again, through the analysis of the data, we were able to identify rivers that had either changed their course or expanded or had additional tributary. And this is showing the Layu River before and after the hurricane. Now, in order to derive more contextual information from our analysis, background data is required to really contextualize and provide appropriate information, such as land use, land cover maps, boundary maps, local cropping practices, again, knowledge of what types of crops are grown where. And sourcing that data took a bit of time and was a bit of, I guess, something that needs to be built and developed in terms of spatial data infrastructure, and the sort of sharing of data between different bodies. So we were eventually able to get some land use data, land cover data from the CARM project that had been done in recent years, just I think a year prior in Dominica. And so by overlaying the results of the backscatter difference threshold and the entropy data on this, we're able to then extract areas where damage to the agriculture sector had occurred. And so this image shows the areas that in Dominica which had suffered the areas of agriculture in Dominica which had suffered significant damage as a result of the hurricane. We can see in particular that the northeast area, which was hit both by Hurricane Irma and by Hurricane Maria, suffered significant damage. And again, this is just, again, a closer view. This is around the Layu River that we had looked at before. Again, we can see that there's a lot of damage sort of around rivers. I guess the impact of flooding as well as wind damage and landslides. So we did a quick validation using one of the apps that GGIS had previously developed. So the CARDI rep went to a couple of farms and using our app, with the app was able to, once he just answers a short questionnaire and sends in the data, then that data is received on our server and we can see on the map the information provided and just simple information as to the level of damage that occurred in each of the areas, and also just what type of damage, vegetable farm, coconut field damage, infrastructure damage, that sort of information. You can imagine if a situation where if many of the farmers have this sort of app, they can then provide sort of more real-time information. But that's something we're hoping to develop further in the future. And so this is just a quick snapshot of what the app looks like. This, again, we also have another one for locust monitoring that's called Foresight Crops as well. So for Antigua, we were not able to source any land cover maps. This doesn't mean that one doesn't exist. It just means that through CARDI and the other partners we were working with, we were not able to source one for during the time frame of this project. And so we then had to work on creating our own, and we did this by using some unsupervised classification algorithms to do this and to just generate some general classes for Antigua. And then we then use this to then, same as Dominica, identify those areas in agriculture that had suffered significant damage. So if we quickly move on, so this is Barbuda, and well, we all know that Barbuda suffered significant damage, and again, this the satellite data was able to identify this. With St. Kitts and Nevis, this is the radar data, and from the radar data, it showed that the impact of the hurricane was restricted to the coastal periphery. This is where we could see changes highlighted in the data. So here we've combined different dates and of one of the channels, the VV channel of the data set, and the green around the coastal areas. Again, this highlights that the potential disturbed areas for St. Kitts was in the coastal areas. So again, the analysis of the backscatter, the coherence and the entropy showed that there was widespread damage across the whole of Dominica. Using the radar data analysis, was able to overcome the limitations of optical data in terms of the cloud cover. And so really with satellite data analysis, you would get the best results by combining both optical and radar data. And again, the NDVI time series allowed the identification of the change in the pre and post in terms of the vegetation loss and the loss and stress and damage to vegetation. And again, we were then able to estimate the total area that was damaged from the analysis. There's also the availability of high resolution imagery. Here, we're looking at Pleiades before and after. This is a 0.5 meter imagery before hurricane. You can see the green lush vegetation around the Lai River, and then after, you can see the stark change where the trees have been stripped of foliage. I'm not sure how clear this comes across, but this is again high resolution imagery, and you can see that the trees have been stripped completely of foliage and have fallen over. There's mudslides and erosion, change in the river course, and damaged buildings. So in terms of capacity building work that we carried out, as I mentioned, I worked with an intern who was a third-year student from the geomatics department of the University of the West Indies. In addition, I held 3 webinars for CARDI and related staff looking at introduction to GNSS remote sensing and geographical information systems, introduction to global navigation satellite systems, including a practical exercise, and introduction to remote sensing. We did some further work. This wasn't initially planned, but some early stage further work was done looking at trying to use the satellite data to determine a signature for different types of crops. Because one of the issues that we had was, in order to be able to put a financial quantity on in terms of what was lost, then one needs to know not just where the damage occurred, but what type of crop was grown there. And that information was not really readily at hand. And this was looking at whether satellite data could be used to identify the different crops. And so we tested 5 plots. This was using the premise that to try to use the crop phenology and the different backscatter characteristics during the growth cycle to create a profile that can then be used to identify different kind of crops. And so we looked at banana, and we could see that the signature was for 4 of the plots were more or less in agreement, but although one was slightly different. This could be that due to maybe a different irrigation regime on that plot, or some other different characteristics. So, I mean, to summarize, in terms of the opportunity, there is a wide array of data available. So there's Landsat data, this is optical data, Landsat data available. There's the European Space Agency Sentinel-1 radar data, as well as the optical Sentinel-2 and 3. For academic institutions, they have available the ALOS Pulsar L-band data sets that's useful for analysis of vegetation and forestry. Again, there's increased availability of drones, data from drones and other aerial platforms. And then we have high processing capacity available by HPC, GPU processing, and increasing availability of cloud computing capacity. And then there's the availability of machine learning. So this project has been a useful project, and it has highlighted the need to develop spatial data infrastructure in the Caribbean region. And I think between 2018 and now, some of this infrastructure has been developed. So for example, CDIMA has the Caribbean Risk Information System platform, where documents related to disaster risk management are available. And I think this was definitely something that would have made things easier for us if it had been available at the time. So I think it's good to see this development, and hope to again see more of developing those pipelines for data sharing across the region. So thank you for listening, and welcome any questions.
Thank you, Dr. Ogundipe. Go ahead and take some questions. Now, if anyone has anything, just a reminder, please be sure to type them into, if you hover over the bottom of your screen, you will see a Q&A tab appear. You can click on that and enter your questions. As we wait questions coming in, Dr. Ogundipe, in the case of Antigua, where land cover maps are not available, which may be the case for other countries in the region. I mean, now that CDIMA has set up CRIS, we are really happy about that. But would you walk us through how you dealt with this during the course of the project?
Yeah, so that was the slide I showed where I highlighted that we then did an analysis using unsupervised classification technique to basically develop the different classes. But ideally, when you're doing land cover map development, you want to be able to have some ground validation. So because of the limitation of the project, we weren't expecting to be able to have to do that. That side of it wasn't there, but the output that we developed was still useful and can be built on further with some extra ground validation.
Okay, great. I see we have a few questions coming in. Nitram Ramnanan, he's asking, have you done any analysis to correlate incidents of landslides with vegetation type?
No, we haven't. So this was really a short project. It was actually intended to be just a three or 4 month project. The extension in time was really because of the time we were waiting for data, really. So it was a short feasibility study, but that definitely is an area that requires further analysis in terms of correlation between landslides and different types of vegetation cover.
There's a follow-up question. Is it possible to do this with the data that you already have?
I guess the question would be, the question would relate to what, in terms of is it possible to identify the different crop types? Because you would need, or the type of plant or the type of vegetation, I think additional background information would be needed in order to extract that kind of analysis. So yes, we would be able to use the data that we already have, but it would need some other contextual information or information from an agronomist or a specialist who would provide information on what type of crop grows on what type of slope, or what type of vegetation grows on what type of slope. So that contextual data would be required to draw out that information.
Okay. We have a question from Shivani Dionarine. She's asking, can you enlighten us on why radar VH polarization was best suited in this instance?
So radar in general was best suited in this instance because of the ability to see through cloud cover. I won't really go through all in terms of the VH or the VV or the so we looked at the different. So with the Sentinel data, you have the different polarization. I think my colleague Mohammed, who did a lot of the radar analysis, unfortunately he's not here, but he would have been the best to really talk through in terms of the polarization. But I think in general, the radar data is best suited in this instance because of the ability to not be limited by cloud cover.
Okay. David Yorson, he's asking, I see Landsat and Sentinel 123. Which optical sensor was used for the Dominica application?
So we used both Landsat and Sentinel 2 for the optical analysis.
Okay. Dorian Etienne is asking, can the geospatial observations and analysis generate correlations on the economic impact of the disaster?
I think it can provide information as part of a wider study, so it would need other inputs. So for example, my GGIS in collaboration with the University of Nottingham's Rights Lab, we've put forward a proposal for funding which aims to look at the impact of natural disasters such as hurricanes on the increase in forced migration and forced labor, for example. So by combining satellite data analysis with questionnaires that the Rights Lab are going to put to people, a questionnaire study and an on-the-ground sort of social study, we can then look at analyzing that impact. So I think that would be a similar thing for the economic impact by combining things like the change in land use, the spread of urban areas, the increasing maybe impact on the nature reserves and that sort of thing. One can look at economic impact as well.
Okay.
But it would need, again, satellite data alone cannot tell you this. You need to combine it with other data sets and other specialisms and other analysis as well.
Right. Nitram Ramnanan, I'm keen to know if bamboo stands up as preventing landslides or predisposing hills to landslides, as it seems to be invasive in Dominica.
I would not. I think this is something that maybe you, Ria, as CARDI, someone from CARDI, because yeah, that's not my specialism. I wouldn't be able to say whether bamboo is good for preventing.
Right. Yeah. I am not able to say either. Is the
issue with bamboo is really, particularly in the Dominica context, is really a function of the kinds of slopes that you have. Right. If the slopes are too steep, any vegetation and thing will create overburden and then precipitate and so on landslides. And that has been the experience and so on with bamboo and other species in the Scotland district and thing in Barbuda. But on the other hand, if on the more gentle slopes and things, then bamboo and things can indeed serve as a mechanism and so on for reducing the impact and so on of landslides. And similarly and so on, couscous grass. In fact, couscous grass probably even be better. Some of the studies and so on have been showing places like China. In fact, if you go into places like St. Vincent, you see the evidence of the use of couscous grass to have to deal with landslides. Thank you.
Thank you, Mr. Clark. David Yosson has two questions. The first one, why was the validation restricted to one or two villages?
It was just really a time factor, really, in terms of it was just one person having to travel around Dominica. So, I mean, if we could have gotten more data for the validation, I definitely would have appreciated it, but that was
Right.
what we could get within that time frame.
At the time, yes. Ability, his second question, ability to assign classes accurately. This has to do with the classification. Ability to assign classes accurately to unsupervised classification image requires local knowledge. That knowledge could permit a supervised classification. Why was supervised classification not done then?
Yes, so like I said, in coming to this, in doing this project, as it was a short project, it was meant to be that we would have these background contextual data to build on so that we would have the land cover maps provided and for the different islands. But it was almost like a stopgap way because we did not have any of these. So it's like we had to do this additional processing, which we were not expecting to do. And we did not have the capacity on the ground in Antigua to be able to do that ground validation, because yes, supervised classification is what would be required with the local information to develop a land cover map. Yes, but again, the issue is, I would believe that there is a land cover map for Antigua. The issue is just accessing it.
Right.
Like is because the issue is, again, the issue of data sharing with the whole spatial data infrastructure, where there is data, but it's in different departmental silos, and it's the fact that CARDI was not able to access these data sets for the different countries.
Yeah. All right. I'm seeing Julio Brian. Can this be used historically, for example, decades before comparisons?
Yes, yes. So historical data is available particularly for Landsat optical imagery going back. So going back to several couple of years, you can have historical data. I mean, it depends on how far back. Obviously, the satellite data are limited in terms of how far back you can go.
Mm-hmm. Okay. All right. Shivani Dionarai, she's asking about erections.
Just before you go on, Ria, I think it's important to note that we have to get into a vein of dynamic monitoring so that we know what is this situation before an event, during an event, and after an event, so that we are then in a better sense to make to generate economic, both physical and economic impacts, right?
Mm-hmm. Correct, and which has to do with what Dr. Ogundipe, you were talking about with the data infrastructure, and so that is just alludes to that, the absolute need for, and I mean, Sidima has already started working it. All right, Shivani Dionarai, how effective do you think the satellite data was, given that there may be agricultural plots in the Caribbean with a size smaller than the resolution of some of these data sets?
So in terms of the data set resolution, so the resolution of the Landsat imagery is 30 meters per pixel. The resolution of the Sentinel is 10 meters. So while the high resolution imagery is half a meter, the one that I used, half a meter. So I think with that, you can even for small plots get information for those.
All right, Yin Yin I think this may be another one for Mr. Clark. How can we prevent the landslide altogether? Yin Yin A.
Well, I mean, there are several approaches and things. I mean, vegetation is one of the ways in which you can think. Then you have terracing, you know, bench terracing or graded contour terracing are also methods of which you can prevent landslides. You have, like in very acute circumstances, an area that I'm very, very familiar with, I think I alluded to the Scotland district in Barbuda, where you have, not only do you have lots of water, lots of springs and streams flowing that precipitates the landslides, but you also have, in some instances and so on, what they call muds, George River muds, which are really long-term and continuous dynamic flow of essentially what is, you know, very, very old volcanic material inundated and things with oil. And then you also have mixtures between muds and clays and sands, and because of that variation and, you know, the differential bulk density that occurs, then that also precipitates the landslide. How we solve the problem in the Scotland district is that we went to the water sources right up at the edge of the escarpment, and we then inserted subsurface pitch fiber pipe that collected the water, and then we then use a series of check dams buttressed by gabions that then took the water from, stopped the water from flowing on the surface, trapped it underground in the pitch fiber pipe, and then led it to the foot of the slope into ponds, which would then be utilized and so on for irrigation purposes. That's how we solve that problem. And this is some work I think that dates back, you know, from the 1950s, and some of that work I think, you know, I mean, I worked in that area back in the 1970s, and the work that we did and thing is still holding up. You know, there have been no landslides. In fact, the landslides you're now getting are areas and so on that have not been tackled. So, and then you have, you know, the coastline in California. You have examples, Italy, the Alps,
Right.
the different methods and so on of helping to manage landslides. Thank you.
Dr. Ogundipe, I have one final question. Of course, we can use satellite data to do a lot of things, like say infrastructure in agricultural areas, you know, like sewage, drainage, water access, telecommunications, etc. You could use it to do a bunch of things. One of the things that you used it to do was to develop those change maps that we saw with, I think it would have been Barbuda. You did a couple change maps, but the one with Barbuda, which showed the stark difference just before the hurricane and then right afterward, trees were stripped of their foliage. What are some other areas that we could use the change maps to help with something in agriculture in the Caribbean, besides loss assessment?
So, I mean, change maps can be used, like I said, for a wide range of things. You know, can be used for, you know, environmental monitoring of encroachment of, say, encroachment of farming into reservation areas, or identifying areas of like slash and burn agriculture. Can be used to track, you know, like I said, the resilience post hurricane, to track the growth and to monitor the growth of the vegetation. So it can be used for a wide range of applications. And again, there are other indices that can be used. NDVI is just one indices, but there are other indices and other analysis that can be used for monitoring things related to droughts, for example. So change maps can be used for drought monitoring, for
Right, yes.
flood analysis, identifying areas that are prone to flooding and those sort of things. Yeah, so there's a wide range of applications.
Right. All right, there's one final question from a Jamie St. George. Can you please share the information on how to access the high resolution imagery and the high...
Oh, okay. I think you were breaking up slightly, but I think the question was about accessing high resolution satellite imagery. So in terms of accessing a high resolution satellite imagery, so for myself as a commercial organization, I had to purchase that high resolution satellite imagery, and they're available from a wide range of providers who, I think you can just type it up into Google, and there are a wide range of providers that would provide. So there's Worldview, there's PlanetScope, there's Pledis. There are a wide range of high resolution satellite imagery, but they are not freely available to commercial organizations. If you're a research institute, for example, post-disaster via UNOSAT, organizations can get access to high resolution satellite imagery via UNOSAT. Yeah.
Okay, thank you. All right, it looks like we covered all of our questions. Dr. Ogundipe, is there anything else you wanted to cover before I wrap up? Or Mr. Clark?
I think for my part, I think it was a good experience doing the project and working in collaboration with CARDI. As someone who partly grew up in the Caribbean as well, it's like seeing the impact of hurricanes and these disasters in the region, to be able to use satellite data to make an impact in that field is definitely something that was of value for me, and also to be able to contribute in terms of the capacity building, again, as a UWI Geomatics alumni. And I guess just wanting to see, the development that, the work that we've done, that it be built upon, and that further work is done in terms of capacity building, but also in terms of data sharing, and in terms of, there's a wider range of medium resolution satellite data available for free that can be analyzed and used to, bring value to building resilience and planning in the region. I think, like I'd mentioned, a couple of projects that we've applied for funding for, and if those are successful, then again, that would, I think, be of significant value. And being able to develop that capacity for, near real-time data capture as well, combining mobile apps with satellite data to be able to develop that area is also an area of value.
Okay, Mr. Clark, is there anything you'd like to add?
Just to indicate that, like I reiterate what I said earlier about the fact that this is about the beginning, because disaster risk management, agriculture, and thing is very, very critical, and that it needs to be endemic within the operations of the national and regional systems. We're very happy for the opportunity and think to have had this experience, and we're also happy and think for the kind of collaboration and so on that we have with CDIMA and CIMH and the 5Cs, which can help us and think to further build on this, because this is very much part of the future that we want in terms of as an institution, as well as in terms of providing enhanced opportunities for the farming community and think to do what they do better. the use of these tools and things, is going to be critical and thing to success. It's not only relating to matters and so on of disastrous management, but normal everyday crop management, pest and disease management, fertilizer management, management of water, and so on are all some assistance can be derived, I think, by appropriate use of satellite imagery combined with uses of drones, so that we can have be a lot more precise in our agricultural endeavor and increase productivity and profitability for the farming community. Thank you.
And just following on from that point, a few projects, some ideas came out of the webinar, which I think I should recap. One was to correlate incidences of landslides with vegetation types. Mr. Clark spoke about the data infrastructure for real-time monitoring of the agriculture sector. So we want to start having data that is just before incidences, during incidences, and after post-incidents. Dr. Ogundipe also spoke about drought monitoring. So there were a few ideas that came out of this webinar series that perhaps, I don't know if some institutions are interested in taking up on this opportunity, and perhaps you could form collaborations with Dr. Ogundipe CARDI and your institution to help to build out some of these projects, because of course, as Mr. Clark indicated, we are trying to build a resilient agriculture sector, and this kind of work definitely contributes to that. All right, so thank you everyone for attending. The webinar will be made available to all participants, and we will see you next time at our other CARDI webinar series, which will be for our CARDI Day in December. We'll send out the invitation. Thank you again for attending. Take care, everyone.
Thank you.